Hello everyone. So in this video, I would like to talk about more on the time series. We'll explore multiple data sets which has a time series data and what are the libraries, what are the functions are mostly used in time series. So to get started, first we need to install these four packages which are mostly used in the time series: the LMEA, Forecast, FMA, FPB2. So you go ahead and do that. I have already done, so I will not going to do it. Let me clear that. And so first we are going to load the FEB2 library, and then we'll look at the A10 dataset. So it's a monthly antibiotic drug subsidy in Australia from 1991 to 2008. And let's see the structure of this dataset. So we can see clearly it's a time series from 1992 to 2008. And if you want to view it, you can view also, but there will be only one column, two columns actually. So before we start with the time series, so there are these two uh, LOES and the GM is the fog flows or the functions. LOES stand for locally estimated scatter plot smoothing, and it's a non-parametric regression method that fits the polynomial to the local area of the data. And the GM is a generalized additive model. It's a generalized linear model where the response variable is a linear function of a smooth function of predicator. So let's do one thing. We, let's convert this data into the data frame A10. And with the ggplot, we are going to see the data. So as you can see, let me please zoom out. So this is the time series data plotting of sales, right? Sales happening with the uh, based on the number of the years, and looks like it's moving in the in the upward direction only. And let's add the so time series data is mostly uh, visualized in the lines. So this is the point. So let's move into the lines. And as you can see, the time series data, for example, is a stock data where the buying after buying and selling the stock always move in and mostly represent with the lines. So here we updated we changed the data frame, and then we use the ggplot to prepare this graph. But autopilot plot automatically it's a function which is from the forecast. Let me load this. So what it does, it's automatically plot based on the data type. So if I directly put A10 in the autoplot function, as you can see, it's generated the same graph without changing anything, right? So if you want to see more detail about the autoplot, you can use that and click on this details. We can add few labels X, Y, and years of the sales and the title also. Let's also see the ggplot title. So this is again it is used to annotate the title, and let's check the different data sets, the gold data sets. So let's autoplate this gold, and this is the gold price with respect to different time. And if you want to see the when is the maximum, what at what time the gold was the maximum, so we can use which for max and the gold data set and to put that into one of the variable, the spike date, and the 769 is the index where all the is the row number where max where the gold price was at the maximum. So here what I'm doing, I'm just first is auto plot gold, which will create this graph, and then I'm annotating. So point, it will create a red point where the spike happens, and also it will highlight this is the incorrect value, maybe because of the wrong value was input. So let me run this and let me zoom it. So as you can see, this is the value which is incorrect. The gold price never went this high, and this is the maybe the data entry was incorrect here. So if you want to look for more annotate, what you can do with the you can create a rectangle or the point range if you want to put that, or text. You can look into the help file and see what are the various options are available. So let's remove that gold value. So we know this is all the value except the minus 770. And right now what I'm doing, I'm just keeping that value, the Skype date value, as the NA here. And let me replot it. As you can see, the spike is gone now. So let me put that one of the geom H line vertically to draw a horizontal line with intercepted 400 and color is red. So as you can see, that's 400. It draws the that line. Let's see the longitudinal data. Again, I will load the FBT2 library and we'll see the electric daily, which is in the used. Let me see. Like, so it is hourly, half hourly, and daily electricity demand for the Victoria, Australia in 2014. And if you use the autopilot, it will draw the this graph, right? So it's a demand, it's a workday, and it's a temperature. Let's create a separate graph. So this is a demand, right? This is a workday, and this is the temperature. So we can see the temperature is high, the demand is also high. Temperature is low, then also demand is moving. So let's see the structure of this data set, and let's only plot the two, right? The demand and the workday, and we are added this geom smooth also here. Uh, Next, let's see the path plot. So path plot is it will draw the points and the path as well. It's a very messy data. And let's add a day of years to the data frame. So I'm creating a new data frame, electricity daily 2, and let we are adding the day as the new column. And let's plot this one. Okay, so this looks still, uh, it's very hard to get the insight from this type of graph. Right? Okay, so let's see where is the highest temperature and the lowest temperature. So again, which dot minimum in this temperature and the highest one. And again, let's plot this. So what is a so if the temperature, this is the lowest and the demand is still high, and if the highest temperature and demand is still very high, right? Spaghetti plot. So we'll use the NLME library and the Oxyboy data set. So what we are doing, we are checking the age and height, and we're grouping based on the subject. So let's plot this one. So this is what we call a spaghetti plot. Right? This is the age and this is the height of the person. Right? So here, what groups specify that there should be one line per subject rather than the one single straight line interpolating out. So as you can see, for each rows of the variables, there is a one line going through it. So let's add some colors. So based on the height. height. So as you can see, the boys' highs are ordered by the height. So let me zoom it, and yeah. So if I add this into Plotly, I think there will be an interactive chart. We'll see that. So we can add one trend line, and let me do that. So again, this is color is based on the subject here, right? GM points, it will create the points and it will add that one line here. So let's see that. So this is what the uh, trend line of a regressing model, right? So in time series, seasonality and plots and decomposition. So seasonality was what how do your lines and the observation are changing based on the month or the weekly. So this is also we can do using the forecast library, right? And let's plot A10. So G is and you will see this is very easy and very informative chart. So what's happening here is based on the months and for different year, as you can see, this air is a air passenger chart. So the demand is very less always. It's come down from Jan to February, right? And let's add the, oh sorry, this was 8 and I was confused with the air passenger. 8 and is it's again the anti-diabetic drug sales. So sales is going down in the February, and let's add the Y uh, and the title. So I think that's why the title and annotation are very important, because you know what this graph actually means. So you don't get confused with the different. So again, the autoplot STL function is will divide into the seasonal component. So if based on the S window represent the number of days you want to divide, and it will get three charts. So the first one is your data, right? Actual data, the trend where it is going, and if it has a seasonality, right? And the remainder where it is at what time it was up, at what time it was down. This is very informative and highly used in the stock market analysis also. Let's see the FMA library, and it has the writing data set, which is again the sales of the printing and writing paper. So as you can see, this, let me zoom it. So sales of the printing and writing paper starting from 1968 to 1978. As you can see, it's in the higher, in the upward direction. So let's see the seasonality plot, and this is very interesting. You see, with the seasonality, we can infer this in these during the August time, the sales always dipped, like in all those years, right? And the reason being, in August there is a holiday season in the France. That's why the sales always did at this time. Very informative, and you get the insight is you can get the insight easily with with this type of graph. Still decomposition is again, it will uh, it will split into different things based on your trend, the seasonality and the remainder. Let's also see the change point. So change point detection is mainly used where if you want to view your data and see when the change are happening in the mean or in the variance. And there is a library called change point, and GG45 is you also used in this. So, this was already installed. So let me load this FFP2 to change point and GG45. So let's plot the A10. Again, this is a diabetic sales, right? And let's make it a new data set called 8NNS, removing the seasonal part, and let's plot this. It looks same. And if you want to see when, plot the points where there is a change in the means, so we can use auto plot cpp dot mean, right? At this point, as you can see, that it's highlighted in the red. So this is where there's a major change in the mean. So let's also change the method to binsec. Right. Now there are more points, right? So there are multiple methods. You can look into the help section and see which method you want to prefer. There are different calculation behind different methods. And let's check for the variance, where the variance has been changed, right? And this will do where the mean or the variance is changed. So this for as you can see, the mean where it was changed and the variance it is here it should change. So we can also plot time series for electric demand, right? So this is the demand, and this is a change in the variance. So you can see that starting at the end, and let's do that again. Changes happening in the starting and the end, and the last one. So why earlier I was checking on the demand, and this is the of the temperature. So we see the very high variance periodic constants that peak with a large oscillation in the temperature, which can cause the energy demand to increase or decrease more than usual, making the variance greater. So the variance is changing in the starting or the end based because there has been change in the temperature. So we can, I think the last one, we can also make this graph. Uh, Once again. me click on this one. So to make this graph interactive, you can always use Plotly library and it will show more information. This is not very helpful, but again, if you want to add your labels or more detail, you can do that and make those things in the very interactive, right? You can see, right? Yeah, that's it. This very high level brief introduction regarding the time series. We'll discuss each and every in detail in later coming videos. But this is the power of the R. Very easily you can get the insight by creating the charts and by doing the calculation. Yep. Thank you.